Yes, very, very offering science subjects, okay? As students offering science subjects, especially physics, we need to understand how resistors can be arranged in an electric circuit. Yes, very, very important. All right? So, and we have got two methods or two ways in which resistors can be arranged. Okay? These two ways are series arrangement of resistors and then parallel arrangement of resistors. So these are the two ways. Here we go. The first one is, first method we are going to, or this thing we are going to consider is series arrangement. Okay? Arrangement of resistors. Right? That's the first one. The second one is parallel arrangement. Okay? So this parallel arrangement, we will look at it very clear. This parallel arrangement. Okay? So these are the two ways resistors can be connected in an electric circuit. There could be other ways, such as Kirchhoff's laws and so on and so forth. But we are not going into that right away. Let us just consider the basic aspects, all right? The basic ways in which resistors can be connected in an electric circuit. All right, so without wasting time, let's take the first one. The first one is series arrangement, okay? We are going to consider the first one, which is series arrangement of capacitors, of resistors, so to say, okay? Series arrangements. Now, resistors are said to be arranged in an electric circuit in series when they are connected end to end. So we can say that resistors are arranged, okay? Arranged in an electric circuit in an electric, okay? In an electric circuit when they are connected, end to end. First stop. When resistors are connected end to end, the conclusion is that they are connected in series. For example, let's see. For example, we said when resistors are connected end to end. So let's show the illustration right away. So if we have a resistor connected in this way, this is the first one, the first resistor, okay, connected to another resistor, all right, okay, this is AP, all right, this is a resistor R1, this is resistor R2, okay. Offering resistances may be 3 ohms, and then this one 4 ohms. We will come to that, okay? This is example 1, I, all right? We can call this I at this point. Good. Then I we have another one. Maybe we have something like this, okay? I'm just going to show 3, but in different forms. So we have another one connected in this form, right? And then we have another one connected in this form. So here, this point we have R1, R2, okay? We have R2, right? And then we have R3, okay? With various resistances, maybe 4 ohms, okay? And then maybe this is 5 ohms, and then probably this is 3 ohms, okay? That is it. Look at this, very simple. What if we have the third one? We have another diagram representing series connection of resistors. Of course, if we have this, maybe it looks like this. It looks this way. Okay? Something like a chain connection, right? Let's look at this. And it comes down again, have something like this. Okay? And we have this. Maybe it comes down again, have something like this. Alright? And it moves, goes up to the final connection. We have another one here. Alright? And then maybe finally it terminates at this point. Look at this. This is R1, R2, okay? This is R3, maybe R4, R5, and then R6. R1, R2, R3, 4, and 5 respectively represents resistors with various resistances, right? All right, so look at this. Why shouldn't be confused with this at all? What it means is that this is a series connected resistors, only that the pattern of connection is quite different, right? If you look at it, trace it down, you will see this is very simple, but it takes a different pattern. Very simple. All right, with that, I have mentioned that we have ohms. Ohms is just the SI unit. So we need to understand that the SI units of resistance, right? The SI unit of resistance is ohms, okay? And it has a Greek symbol given as this. So we must understand this. The SI unit of resistance is ohms, and it has that unit. Very simple. Now, in all these arrangements, if we want to calculate the total resistance in a given circuit, maybe this circuit that has R1, R2, or maybe this circuit that has R1, R2, and R3, respectively, if we want to calculate the total resistance, there is a formula, and that formula is given as RT, okay, is equals to R1 plus R2 plus R3 dot plus Rn, okay, this should be plus dot plus Rn. What does it mean? Look at this. Very simple. This simply means if we have three resistors, such as we have in figure II, 1, 2, 3, it means we are going to use R1, R2, R3, and stop at that point. Then we sum. It's just a kind of algebraic sum of the resistances we have here, right? And I would say that resistances is measured or has an XI unit. XI unit simply means International Standard Unit of Measurement, okay? Of resistance. This resistance is ohms, all right? That's what it means. Okay, so whatever we calculate, if we calculate this now, whatever it gives us must be in ohms. That's the unit of measurement. Very fine. All right, having said that, there are other things we need to understand here. There are other few things we need to understand. And then that will come in a very short period of time that will help us understand that we have been able to show how resistors can be connected in series. So we can still take note of the following. We need to understand, first of all, that the current flowing in an electric circuit, take note, the current flowing in an electric circuit, when such circuit involves resistors connected in series. In resistors connected in series connection of resistors, we must understand this. Connection of resistors, all right? in series connection of resistors, the following must be taken note of, comma, we must know, we understand, okay, that one, current flowing in a series connection of resistors is the same. Current flowing, all right, is the same. We must know that. Very, very important. That's the first thing. Once the connection has to do with series connection, current flowing along all the resistors is the same. Then the second point we need to understand is that the potential difference across each resistor, difference, PD, the potential difference, all right, the potential difference across each resistor is not the same. PD is not the same. It's not the same. All right, it's not the same. Very simple. That's what we need to understand. That the potential difference across each of the resistors connected in series, all right, end to end is not the same. Take note of this. Potential difference across each of the resistors connected in series in an electric circuit is not the same. The only factor that is the same is current flowing. Current flowing is what? The same. Current flowing in each of these resistors is the same. That's one thing we need to understand. All right. So having understood this, it is time for us to seek your contribution. Support us by sharing this to students who might want this, by hitting the bell button for constant notification each time something like this is uploaded. Also give us some thumbs up, all right? Then don't forget to subscribe. Most importantly, subscribe. That red button there, subscribe, so that people who need this will get it along the way. All right. Thank you very much. Now, how to calculate? Take it from me. How to calculate resistors with their various resistances connected in series is the next video you are going to watch. You will now see how to calculate the total resistance of resistors connected in series. I will be linking it up somewhere there.